If you've spent any time at all, I mean, any time, trying to automate stuff on the web, you know this feeling, right? This like sinking frustration.
Yeah.
Your script, maybe it's Python, you spent hours getting it just right, and then bam, it crashes. Why? Because someone changed a font size, shifted a CSS selector, or, oh, the worst.
Yeah, the random cookie banner pops up, or a GDPR notice, or a login redirect you didn't expect.
Exactly, that brittleness.
Yeah.
It's just the constant tax you pay with web automation.
It really is. It's been the headache for, what, a decade? You build something based on how a site looks today, and tomorrow the web just changes. It breaks your assumptions. But the source material we're digging into today, this detailed look at Gemini 2.5 computer use, feels like a pretty fundamental change to that whole problem. So our mission here is to really unpack how this engine gives an AI, well, effectively, eyes and hands inside a real browser, allowing it to see the screen visually and operate the controls like a person would.
Okay, eyes and hands, I like that. And the source material, it calls the agent a patient junior engineer who never gets tired. That's a great image. But, I got to push back a little immediately. Junior engineers, patient or not, they make mistakes. They get stuck. They definitely get confused sometimes. How does this avoid that? How does automation, which needs to be reliable, deterministic even, stop the AI from just getting lost in a messy UI, or worse, getting into some infinite refresh loop?
Right, and that's exactly the skepticism you should have, because the architecture is actually designed with those risks in mind. This isn't just, a general chatbot trying its best. It's a specialized AI service. Its job is really focused, take a goal, plan the steps, execute them, and this is crucial, provide evidence it did the job. And the Gemini 2.5 computer use engine, that's the specific part that lets the agent operate a real browser. We're talking human-level actions.
Oh.
Logging in, scrolling complex pages, filling out tricky forms. Basically, all the important stuff that happens behind interfaces that were built for people, not APIs.
That distinction is so important. We'd all love clean APIs for everything, wouldn't we? But the reality is so much high-value work. Think logistics tracking, compliance checks, vendor portals. It's all still locked behind standard web forms. We need a way to automate those visual tasks reliably. So, okay, let's get into the mechanism. How does it enforce that reliability? The source boils it down to 4 verbs, which I found really helpful. See, think, act, repeat.
Exactly. That's the core loop. It starts with C. Your code, maybe you're using Playwright, Puppeteer, whatever, it just takes a screenshot of the current browser window, everything visible. Then comes think. The system sends that screenshot plus the overall goal and maybe a bit of recent action history over to the Gemini 2.5 computer use model. The AI looks at that picture, understands the context, and decides, okay, what's the single most logical next thing to do?
And that leads to act.
Okay.
So the AI doesn't do the action itself, it tells your code what action to take.
Precisely. It might say, navigate to this URL, or click at these coordinates, or type this text into that field, maybe scroll down, or even trigger a keyboard shortcut like strcall or S.
Okay, your client code performs the action, and
But then we repeat. Take a new screenshot of the result, send it back with the goal, and the loop continues. See, think, act, again and again, until that original goal is clearly met.
Having that auditable trail, the screenshots, that sounds compelling. But it only works if the back and forth between my code and the AI is simple and predictable, right? What's the actual technical contract look like?
Yeah, it has to be minimal. Technically, the engine needs just 3 things. The instruction, find the gold price, the current screenshot, and maybe a short history of recent actions. And what it gives back is super structured. It's basically a function call representing the next UI action, like click at XY or type text at XY text. This predictability is key. It means you can log every step, audit the process, and actually trust integrating this into a real workflow. It turns it from a cool demo into a dependable tool.
Okay, so you mentioned screenshots, visual interpretation. Naturally, the scope question comes up. Is this just for web browsers? Or could I use this to automate, say, a desktop app like Outlook or Excel?
Good question. The source material is pretty clear on this because it relies so heavily on seeing the browser's visual state, the DOM, the screenshots. It's fundamentally a browser-first tool. It seems to show a lot of promise for controlling mobile web UIs too, which is interesting. But for anyone thinking about controlling the desktop OS itself, opening local files, clicking system pop-ups, yeah, that's currently outside the scope here. The focus is really on taming the web.
Got it. Browser first. That makes sense.
Yeah.
Excellent context.
Okay.
Let's make this more concrete. Move from the theory of the loop to a real example. The sources walk through building a gold price bot. And the goal sounds simple, but it's actually got layers. Find the live gold spot price for XAU on a reputable site. capture the numeric price and the visible timestamp, return a 3-bullet summary with the source URL, and save a screenshot as proof.
Right, that task is a perfect example because it hits all the key agent strengths. There's navigation, finding a reputable site isn't trivial. There's extraction, pulling out specific numbers and text from the visual layout. And then there's synthesis, creating the summary and packaging the evidence. It's not just clicking buttons.
So practically speaking, how do you set this up? The source mentioned things like screen size.
Yeah, for consistency, it suggests setting a standard viewport size for the browser the agent uses. Something like 1440 by 900 pixels seems to work well. It just helps ensure the AI sees a consistent layout each time.
Okay, and that brings me to something I thought was really clever architecturally. The coordinates. The AI doesn't say click pixel 824 by 512, does it? It uses normalized coordinates. How does that work?
Yes, the normalization. This is, I think, one of the smartest bits because it directly tackles that brittleness we talked about at the start. Instead of pixel values, the AI says something like, click at normalized coordinate pikes 550, y 300. These coordinates always run from 0 to 999 regardless of the actual screen resolution. Okay. So 00 is top left, 999,999 is bottom right, no matter if it's a tiny laptop or a huge monitor.
Exactly. It completely decouples the AI's visual reasoning, click the middle button, from the physical pixel layout of any specific screen. This makes the whole system way more robust and portable. Run it anywhere.
So that little adapter layer you mentioned, the client code that's actually driving the browser with Playwright or something,
Yeah.
its job is to take that normalized 0999 value and translate it.
Yep. Translate it into the specific pixel coordinate needed by the browser driver to actually move the mouse pointer and click in the right spot on that particular screen.
Okay, that makes sense. The AI gives the standard instruction, your code handles the local specifics. Right. And the AI's output is predictable. Those function calls like navigate, click it, type text hat, your adapter code just needs to handle that limited set of commands. So if we pull it all together, what do you need for a real shippable agent? 1, clean, unambiguous goal prompts. 2, really clear finish criteria. How does it know it's done? And 3, that mandatory strong evidence, the final screenshot, the URL trail proof it did the work.
Okay, this sounds incredibly powerful, which naturally leads to the big counter question, safety, trust. If this agent can navigate complex sites and click buttons and fill forms, what stops it from doing something disastrous? If I let it run in a browser session where I'm logged into my bank or maybe a corporate purchasing system, what prevents it from accidentally confirming a huge order, a $10,000 shopping cart checkout?
That's the critical question, and it's addressed directly with built-in safety guardrails. This isn't optional, it's core to the design. The sources emphasize that Gemini 2.5 computer use includes this dedicated safety service that runs on every single proposed step. Before the command even gets back to your application, it inspects the action. Does it look risky? Is it near a button labeled confirm purchase or checkout? Is it about to click download all customer data? Is it typing into a send message field? If the safety service flags the step as potentially high risk, it attaches a specific flag to that action, require confirmation.
Okay, so it doesn't block it outright, but it flags it.
It flags it. And the rule is your application code must honor that flag. If that flag is present, your automation loop has to pause.
It pauses and asks a human.
Exactly. It needs to present the proposed risky action I'm about to click submit payment to a human supervisor and wait for explicit approval before it's allowed to proceed.
That's the essential human in the loop moment.
Yeah.
Mandatory pause button for risky clicks.
Yes. It's non-negotiable for implementation. The human must be kept in the loop when there's potential for real-world consequences. And developers can add more layers too. You can give the agent system instructions like never click anything related to account deletion, or you can force confirmation for specific sensitive URLs, or even element IDs, are critical. Sandboxing the browser is also, obviously, highly recommended.
Okay, safety addressed. Let's talk brass tacks. Cost. Is this actually feasible to run at scale? We're kind of used to API calls being fractions of a penny. If we're sending potentially large screenshots continuously and getting back detailed instructions, what's the damage? The preview costs mentioned are per million tokens, which is a bit abstract.
Right. Thinking purely in tokens can be misleading. We need to frame it in terms of cost per task. Well, yeah, the model is price per token. I think it was at 1.25 per million input tokens, $10 per million output for one tier. The key economic insight here is the cost for a typical short utility task.
Can you give an example? Quantify that a bit.
Sure, take our gold praise bot example. Maybe that takes, say, 8 to 12 steps, involves maybe 5 or 6 screenshots back and forth, and generates a modest text summary at the end. The sources suggest that kind of task is expected to cost Well, cents per run, not dollars.
Hmm.
Probably low single-digit cents.
Cents per run. Okay, that is compelling.
It's a potential game changer, right? When you shift automation for these routine, annoying tasks from brittle scripts that need constant fixing to a resilient AI loop that costs just pennies each time, suddenly high-volume automation becomes practical for a whole class of problems where it just wasn't economical before.
Cents per run definitely lowers the barrier. Okay, final big question before we talk applications. Performance. Does it actually work better than other approaches, or are we trading one set of frustrations for another? What do the benchmarks say?
Performance looks really strong, actually, especially on tasks involving those complex, messy, real-world websites. On standard benchmarks, things like Mind2Web, Web Voyager, the Gemini 2.5 computer use model shows results that are competitive with and often better than other leading models like Claude Sonnet or OpenAI's own agent model. I think the source cited something like an almost 80% success rate on the Web Voyager benchmark, which is known for being pretty challenging.
Benchmarks are one thing, but practically speaking, where does this win? Where my existing Playwright script keeps failing? What's the real-world advantage?
I think it wins by surviving the chaos. It handles pretty gracefully that whole mess of real UI states we talked about earlier, those unexpected pop-up modals, login redirects that bounce you around, content that shifts after the page initially loads, the stuff that instantly breaks selector-based scripts. The visual understanding lets it adapt, kind of like a human would, in real time. And that saves development teams huge amounts of time they currently spend just debugging and patching brittle selectors.
That resilience. It really does open up some powerful possibilities. Let's maybe brainstorm some practical recipes, things listeners could maybe implement fairly quickly to get a win using them.
Okay, yeah. Let's start with tasks needing cross-site data gathering plus proof. Live market sweeps are a great fit. Think monitoring commodity prices, like our gold example, or maybe dynamic flight rates across several airline or travel sites. The key is getting the price at that moment and having the screenshot as undeniable proof maybe filed away automatically.
Okay, market sweeps, that makes sense. What about internal processes? Lots of tedious back office stuff.
Oh, absolutely. Think about back office intake. You often have crucial data coming in from external sources, maybe PDFs, maybe scraped data, and it needs to get into some secure internal web application that has no API. This agent can handle that form filling, and because of that require confirmation flag for critical steps like submit, you can automate maybe 99% of the data entry, then just have it pause for a quick human review before the final commit.
That's smart. Using the safety feature as a workflow step. What about for engineering teams themselves?
Yeah, I love this one. Using the agent as a UI test fallback. Imagine your main automated test suite, maybe built with Playwright or Cypress, flakes out. It happens, right? Instead of just logging an error, you could immediately trigger this agent to try and complete the same user journey, but visually, like a human would.
Okay.
If the agent succeeds, you know the underlying feature probably isn't broken. It was likely just a flaky selector or a timing issue in your main test. If the agent also fails,
Then you have much stronger evidence that the actual user path is broken.
exactly, it helps triage failures faster. Is it a test code issue or a real bug? The agent's attempt gives you a quick, human-like data point. It captures the failure state with a screenshot, records the steps, speeds up debugging dramatically.
Okay, I see the value in triage now. That's clever. All right, maybe two more quick ones. Focusing on high-touch, often manual service team tasks.
Definitely. How about a support triage copilot? Imagine an agent that can log into multiple different vendor or partner portals, pull the latest status updates on support tickets, and then generate a concise end-of-day summary report for the team, with links, maybe even screenshots attached as evidence for each ticket status.
That would save a ton of clicking around.
For sure. Or think about recruiting research. An agent could scan various job boards based on criteria, maybe verify specific candidate details on LinkedIn or GitHub, and then add structured findings directly into an applicant tracking system or a shared spreadsheet. Again, tedious multi-tab manual work made automatic.
Yeah, you can really see how automating these multi-step cross-application web tasks becomes feasible. It feels like a definite shift.
It really does. We spent, the last decade plus trying to force the messy dynamic web into the neat structured boxes required by code, writing brittle selectors, dealing with constant breakage. Gemini 2.5 computer use kind of flips that. It says, let's give the AI the visual understanding and the basic hands, the clicking, typing, scrolling that a real user has. But let's hold it to a high standard with safety checks and proof of work.
And the results seem to be genuinely useful, dependable automation.
The browser agent isn't just a cool tech demo anymore. It feels like it's crossing into being a shipped, performant tool that you can build real things with. The momentum is shifting from, can we do this, to what should we automate first?
Okay, so let's leave our listeners with that. Here's the final provocation for you. Go find a win for your team this week. Identify just one workflow, something painful, tedious, manual, repetitive that involves interacting with websites. Wire up the minimal loop.
Define a clear goal, define a clear done state, make sure it captures proof of work.
You heard the potential numbers. Cents per task for short jobs. The performance benchmarks look strong. The safety guardrails are there.
If you build software or manage processes that rely on web interfaces, now really feels like the time to experiment. Get that minimal loop. See, think, act, repeat, integrate somewhere in your stack. Start building that momentum. Honestly, the main thing slowing you down now is probably just picking that first concrete goal to automate.